Hello everyone, so today we have the lab number 3 and it is about the osmosis. So this is the short video about the plan of the lab. Okay, so we have the 4 consecutive videos for this lab, and during each of these videos you will be doing some part of the experiment. So during the first step you are going to prepare the concentrated sucrose solution, and it will be 1.2 mole per liter concentration, and you're going to prepare 100 milliliters. So why do we give it to you? Because in the previous lab, during the lab math, you did not see how to prepare the real solution. So in this case we are going to show how to do that. So since you know all the formula, etc., and because we give the molarity, you need this molecular weight of the sucrose, which is 342.3 grams per mole. So now we know the volume, the concentration, and the molecular weight. So what we need to do, first we need to calculate the needed amount of sucrose for this preparation. Then we are going to weigh it using the scales. Finally we add some water, and after mixing it we bring to volume of 100 milliliters. So this 100 milliliters is our needed or desired volume. And if you remember from the lecture, the mass is equal to molecular weight times concentration and times volume. So in this case it's really easy. So we have 342.3 gram per mole times 1.2 mole per liter times 0.1 liter, and it's roughly 41.07 grams of sucrose. So this is what you're going to weigh, and after that you're going to put it in the beaker. So you have a beaker, you put everything inside, so it's 41.07 grams of sucrose. Then you add to about 50 milliliters of water, and of course it's distilled water. Then you're going to mix it very well, then bring to the volume of 100 milliliters, again with distilled water, and mix it again, so you have a good homogeneous transparent solution. And of course this solution will be 1.2 mole per liter concentrated. So during the next step video you will have to get familiar with dilutions, and in this case instead of preparing 0.8 and 0.4 mole per liter concentrated solutions, we are going to dilute 1.2 molar sucrose to these concentrations. So in this case you will know both how to prepare the real solution and how to use one as a stock. So going from stock to working solution. Okay, so what do you need to know? First you need to determine the dilution factor, and the dilution factor, which is also written as dF, is equal to C stock divided by C work. In this case we have 1.2 molarity as the C stock and 0.8 and 0.4 as your work. So for both of them you will need to calculate the dilution factor. After that, after you have identified the dilution factor, you will need to identify the volume that you need to take to obtain these and these volumes. So these are final volumes for our concentrations. So how do you do that? Again, you have a formula which goes C1 V1 equals C2 V2. So C1 is here, C2 is here and here. So the V2 you have it here and here. So finally you can go to your needed volume of the stock that you need to dilute in. So for example, we go from the dilution factor, and for the dilution factor, of course, it will be V work divided by V stock. So this equation comes from this, and again this is the mother formula. Okay, so the dilution factor for each of our cases will be 1.2 divided by 0.8, which is 1.5, and for the second one it's 1.2 divided by 0.4, which gives us 3. So the dilution factor 1 and dilution factor 2. Okay, so now we need to identify the V stocks. So let's call V stock 1, which will be equal to 45 milliliters. So here you can see them, and you need to divide it by 1.5. So this is the dilution factor 1, and if you take the formula, which is dF equal V work divided by V stock. Of course, from this formula we have the V stock equal V work divided by dilution factor. So from this formula we obtain this one. So here we have 30 milliliters, and for V stock 2 we have 60 milliliters divided by 3, which is 20 milliliters. And as you can understand, this is the volume of the stock solution that you need to take and then bring volume to 45 and 60. So for one beaker you're going to transfer 30 milliliters of 1.2 molar concentrated sucrose and then bring to the volume of 45 milliliters. So for the second beaker you're going to transfer 20 milliliters of 1.2 molar concentration and then bring to the volume of 60 milliliters. So this is B2V. Okay, so this is the easy part about the dilutions, and it is only to show you how to make the real life dilutions. But for our experiments we will be using 200 milliliters of water. So in the next video. That's why we will need to prepare much more than we prepared in the step 1 and step 2. So this will be prepared for you, and you will be working, in the third video you will be working with these 200 milliliters of each solution. Okay, so on the step 3 video you will be shown the pre-soaked dialysis tubes. So in general they go very dry and firm tubes, and you need to pre-soak them so that they become soft. In this case we pre-soak them for 10 minutes. So we prepare 4 beakers and label them DWDW, which means distilled water in distilled water, then the 1.2 molar sucrose in distilled water, 0.8 molar sucrose in distilled water, and 0.4 sucrose in distilled water. Then what we do, we take about 5 milliliters into each of these dialysis tubes. Then we close both sides of the dialysis tube so that nothing leaves it. And after drying these tubes, so we remove all the liquids from the surface of these tubes, we determine the mass of each of them, and after that we transfer these tubes into the beakers. Okay, so what we do next, we fill the beakers, these ones, with water. So this is distilled water, and we bring to the volume of 200 milliliters. So lastly, we prepare the tubes with distilled water only, and after weighing these tubes, we place them into our solutions, so the sucrose solutions, so into each of them. And after that we leave it on the bench for 45 to 60 minutes. So in the last video you will be shown the results. So after 45 minutes we removed the dialysis tubes from all the water and solutions. We removed the water again and determined the masses. So you will see these masses and you will need to document the changes of the masses. So in your lab books, in the results section, you will have your table with all these changes, and also you will be drawing the graph that actually shows the percent change of the mass related to the concentrations of these solutions. So that is it. So there is nothing more that we're asking you to do, so just watch the videos.